name is Strathmore from the Smart Organization, and I'm also a student at the University of Hohenheim. I'm happy to be learning with you.
My name is Nairobi. I'm the founder and the CEO of a off-grid solar company known as Strathmore.
And the name, they have a brand called SERC. So we basically deal with financial service associations within the country. And the reason why I'm very interested in this particular conference is that we have a huge gap in terms of cooling systems. We have clients who have been asking for such, and it has been quite a challenge to be able to fulfill that gap in the market. So it will be very interesting to see what you have on offer and how can we meet that gap in the market. Thank you very much.
Good morning, everyone. My name is Cyprian. I work for the International Committee of the Red Cross, SERC, and the Environment and Sustainable Development Unit. The reason why I'm here is because, as you know, that Red Cross works in conflict and remote areas where it's not always possible to get connection to the grid. So we rely largely on a solar system.
My name is Thomas Mugu. I work at the Strathmore Research Center. We have been in the team for the week. I've learned a lot, especially on productive use of solar, and I'm happy to see this.
My name is Tobias Zwinner. I'm representing the company Faisam, doing for the cooling unit which is presented today, the distribution.
Hi, I'm Peter Zinger from ID Solar Solutions in Zambia, a private company with fuel solar energy.
My name is Josephine Botero. I work with German International Corporation, GIZ, Proclima. We are promoting the natural refrigerants.
My name is Wilson. I come from Zambia. I work at a training institution, government-owned training institution. It's a technical training center. And we have a solar energy department we want to establish and try and integrate the system with the training program.
My name is Lama Shambuli. I'm coming from Zambia. I'm currently working with Immersion Cooking Solutions. We're dealing in various solar units.
Good morning, everyone. I'm Kelson Maluma, a registered engineer in Zambia. I'm associated with the Association of Civil and Building Engineering Contractors in Zambia. Also involved in skills training. As with any technology, I think once you roll out technology like this, the skills transfer in terms of maintenance and training is important. So we hope we can actually roll out skills training in this part. And also to help GIZ in Zambia who are supporting new farmers in southern province of Zambia to assess the stability of this system.
Then I'm going to teach my name and work for Sundancer. And Sundancer, we deal with solar medical and solar for home systems and solar vaccine units. And we are implementing various projects around East Africa. And the main reason I'm here is basically for networking and actually learn more what is new in the solar space.
My name is Alex Magaya. I'm a mechanical engineer and I'm assist students for University of Hohenheim.
My name is Alexandra. I work for GIZ in Zambia. We came here with a team of 6 to assess the suitability of this system for our purposes in the dairy value chain.
Good morning, my name is Sven from Zambia. I work with the Association of Civil and Engineering Contractors and Chamber of Frankfurt, and we run the project with the Vision Trends.
My name is Lisi Kirschke. I manage the East Africa Hub for Powering Agriculture. Hence the title, but essentially what we're doing is we're looking at renewable energy and energy efficiency solutions at the level of agricultural production and along value chains. And the solar cooling systems championed here are part of our portfolio.
My name is Bashir Mahmoud. I'm from Somalia. I'm also electrical engineer. We came here in order to look at the cooling system solar because there is a need, huge need in Somalia for agriculture because the crops are dying because of heat. So this alternative solution is something we
Karibuni sana once again. We are really happy to host you here. It was just interesting to listen to the mix of participants in the room. We have people from Zambia and from Somalia, so it's good that we're very regional.
And at the same time, we are all in one big happy family. We'll be preaching to the choir. In fact, I think the things I'm about to say you already know, but I'll say them nonetheless because I planned to say them. Sorry. So solar cooling is something that we are very aware of. It's very important for us, both from the agricultural sector, from the health sector. I think I had someone saying they're selling cooling units to people in clinics. For us as a country, we are looking at it in terms of reducing post-harvest losses, in terms of giving people bargaining power. As you know, especially like perhaps in the fishing communities where they go, they get their fish, and then they have to sell it immediately because they don't have the ability to preserve them. So this is one of the reasons why we're very happy about these mobile units. It's something that we can easily transport. We can use to produce ice, to give fishermen as they go out into the lake. You can also have people who are selling ice, by the way. I don't know how many of you remember in primary school. I hope this does not reveal my age. But how we used to buy ice at the gates. Remember the flavored ice we used to buy and eat? That's giving people a source of income. The other good thing about these units is that it's something that hopefully we can locally produce. So looking at building our local capacity in terms of job creation, and I don't have to repeat how bad the job situation in the country is. So this is an important workshop, and I wish you fruitful deliberations.
Thank you so much, Sarah, for the warm welcome. I would also now like to invite Ben McKenzie, who is working with the East Africa Hub of GIZ's Powering Agriculture Initiative. This is, for those who don't know, a multi-donor initiative that is supporting the use of renewable energy in agriculture. So we are also very delighted and very honored to invite McKenzie here to share some words with us, because GIZ has been a wonderful supporter and funder, especially for this work.
Good morning. Thank you very much, Juliet. You sort of throw me off. I prepared a well-structured speech. My name is McKenzie. I'm with the GIZ program, Sustainable Energy for Food or in Agriculture, whose main mandate has been to promote the integration and utilization of clean energy technology in agri-food value chain. So most of our activities revolve around 4 key thematic areas: solar power irrigation systems, passive control, solar drying, energy efficiency, and cooling. The reason as to why we are here today. So maybe some very quick first. Sarah has mentioned post-harvest losses scenario. We're talking about an approximate 1.3 billion ton of food which is lost worldwide per year. This translates to approximately $4 billion which goes down the drain. What $4 billion can do is feed approximately 48 million people in sub-Saharan Africa. Very comfortable. So post-harvest losses is an issue. And interventions which go towards taking care of this issue basically imply that several things are going to happen. Number one, we're in a position to reduce our actual inputs towards producing more food, because now we're saving money that otherwise being lost. And this consequently leads to a reduction in the environmental footprint, which would have come as a consequence of producing more food. The University of Hohenheim has put quite a bit of research into solar cooling. They've actually been working on it, I think, for the last 5 years or so, aspects of which have been funded by GIZ, and I'm sure the presenters who are going to come after me are going to discuss more about their work on this. But essentially, for the last 4 days, since Monday, during this DIY workshop, they have set out not only to build capacity, but actually to demonstrate that it is possible to develop and fabricate these solar cooling units, which are very self-sufficient, easy to maintain. But my favorite part is it's actually possible to do them locally at a very reasonable cost. So without further ado, let me welcome you once again to this workshop. Looking forward to interacting with each of you on a one-on-one basis, but also to learn more from the hosts and the university. Thank you very much.
Thank you so much, Ben and Sarah, for providing some background information as to why this event is so important, not only for the people in the room, but also for those that might benefit within the different nations that you're representing. I'd like to take this opportunity to invite Victor that will lead us through a presentation on the team at Hohenheim and also some of the work that we have been doing related to the topics we shall discuss. Thank you.
Thank you very much. So I guess at the time you are asking yourself where Hohenheim is. So I'm going to give you an overview where we are. We are in south of Germany, very near to Stuttgart, also very close to Switzerland and France. We are a small university with 9,000 students in 3 faculties: agriculture, natural, business, economics, and social science. And we belong to the Institute of Agricultural Engineering, which has 5 departments, 150 staffs, and as you can see, we have a very green campus, a lot of rain, we don't see often the sun. But we have a very cool group called the Tropics and Subtropics group, led by Professor Müller. And we do their solar cooling, but also solar drying, irrigation systems, plant oil extraction, use of biogas and biomass, and a very important topic, post-harvest technology, energy efficiency for post-harvest machinery. And as you can see, we are around 30 staff with PhD students, postdocs, and coming from 15 countries, so we are quite abroad. The solar cooling team you have already met. There are 3 missing colleagues, Kilian, Muat, and Anna. We would like to mention them. They are also part of the team. And part of our facilities to develop those cooling systems that you are seeing here are a climate chamber and a PV simulator. As you can imagine, for solar cooling system, it's quite important to simulate the weather, the ambient temperature, and at the same time the availability of PV power. Since, as you know, the cooling systems are not so efficient at high temperatures, but there you have solar energy, and at night we don't have solar energy, but the systems are working very efficiently. So it's a tricky design what you need to use there. As I mentioned already, we work since 2014 on this topic, and we have been supporting commercial available solar refrigerators. So we'd like to show you the systems we have in the field at the moment. It's just a solar refrigerator that we have converted to be an ice maker, and a smart ice maker with a kind of intelligent control unit, and as you can see here, also having a fan and an ice storage of 50 kilo. This is the commercial version of what we are showing you here today, the ice maker for local production. And for that we developed an insulated milk can, as you can see here, with an ice compartment where you put the ice here inside and can cool down the milk as soon as you have finished what you're milking. So this has been a very interesting technology for milk cooling on farm, at farmer groups, and even at small cooperatives, not only for transporting the milk, as you can see here, but also for storing the milk overnight. So the first thing we would like to do today with you is to take you through our experiences on the field so that you can understand also the reasons why we decided to go for local production. So I would like to welcome my colleagues, Farah and later Juliet, to talk to you about that.
Welcome everyone. So the idea behind this presentation, which is about chances and challenges of introducing refrigeration to agricultural value chain, is to introduce to you some aspects that we've learned from the field. So, and to give you a little bit about our past, because by knowing our past, you will understand why we are right here today. First thing is we are going to talk now about the commercial refrigeration that we have put on the field. The first thing that we did in 2014, 2015, we went to Tunisia. We said we want to see if our system works on the field, so it was for proof of concept, of course. The nice thing was there was no cooling on farm level in Tunisia.
And this gave us the opportunity to introduce our systems. We went there with 10 systems, put them in 7 farms, and we saw that our system is working very good. However, after 2 years, no one was using our systems anymore. And this made us think, what did we do wrong? Very important to question yourself sometimes, to change your strategy and to think very wise. So we said, what was our mistakes? Well, first of all, we didn't adapt the technology to the demand. So in Tunisia, the farmers, they have more than actually 60 liters per farm. We gave them a system that can put only 60 liters per farm. So it was not possible for them to make any profit out of it. Second thing is in Tunisia, they like to work with tanks and not cans because they have a higher production, of course. Third thing that was there was no payment for the quality. The farmer is asking, why am I doing all this job if not? And it was our mistake to put our systems there in the first place. We should have studied more the site. And here comes the idea of the second topic that we had, which is study the adoption of such systems and technology in Kenya. We have the chance to be in Western Kenya for a while now. We've been working there for 2 years with GIZ corn agriculture. And here we wanted to think about the value chain. So I will go a bit in detail so you understand how we did it. The value chain in Kenya is very different from Tunisia. So we have 80% of the value chain, dairy value chain is informal. By that means that the prices are different between the different stakeholders, between cooperative, between farmers, between hawkers, and then you have the problem with seasonality also. That means in the wet season you have too much milk, in the dry season you don't have enough milk, and that's a problem. Therefore you have fluctuation in the prices, of course. We have a poor cold chain, so actually people are only pooling in the milk collecting center or at the cooperative level, at the processor level, but during the transport from the farm there was no pooling, and on farm level there was no pooling also. Therefore, we had the idea of what will happen if we collect the evening milk, because the evening milk is not collected anyway, and this is because they have very poor preservation methods, so they put it in water baths or they coin the milk. And all of this, there were some practices that are poor, so they cannot necessarily sell their milk the next morning. That was the challenge. So the objectives of our studies were clear this time. We would like to see what is paid for such systems, for such pooling systems. We wanted to understand the factors that would influence the adoption of such technology, and finally explore the socio-economic dynamic around such systems. So the methodology was, first of all, we would like to do the site selection criteria. We are not going anymore to the field with the system and choosing there. We took our time, we took 3 to 4 months to do this actually, and then we arrived to the sites that we will show later. We had a 3-month trial phase. That means that before having the agreements with the farmers and with the cooperative to pay for the system, we said you have the right to test the system and then decide, are you willing to start this with us or not? And then we signed agreements, and afterwards we said, now we will come always. So it's not that we put the system and they have to send us the money and that's it. No, we were going on the field very continuously and regularly. And we did many questions. So we asked them, we did so many structured interviews, we did participant observation and then group discussions. So now to our sites. We were in Kakamega and we were in Bungoma. So in Bungoma, we were in Kakamega, we were in Bungoma, and that's a dairy cooperative that decided to own the system. The second part was in Kaprama, and that's a farmer's group. The idea was, as I said, to collect the evening milk, so you can here see that the individual farmers will go to a collecting point, bring their milk. The milk will be cooled here, so they have 40 liters that will be cooled, and then they will sell it, either to the local market or to the processor, but at the end, based on the profit that they will make out of this milk, they will pay for the system. Now a little bit about the results. So the maximum capacity of our system is 1,200 per month. And we see here that actually in this place in Rukumo, where we have 14 farmers that were actually bringing their milk during the year, we see that they were successful to bring the total amount in August. And then we see this huge drop in September, so they didn't bring us the milk anymore. And then there was a problem to get it back to a higher production. This was the first thing that we noticed here. And one problem was the seasonality. But then you will tell me seasonality means in the wet season you have to collect more. You don't collect less. And mind here, actually this is the wet season. The problem is because it's wet season, when you are selling to the market, the prices are lower. So this is the problem. There was a delay in the prices, the prices were lower, so the reaction was very instant actually here. If you take a look at the second place in Kaptama, and this is a farmers group, so they don't work with the cooperative. You see here we have total 30 farmers. The other ones, they have 14 farmers, and here they have only half of the capacity. The question is, what is the difference between both regions? How come these people with 30 farmers, they are bringing half of the others? The simple question is that the two areas are totally different. So the production per farmer is also much different, and the people in Kaptama, they have fewer milk volumes. No? But nevertheless, we see the same pattern. In the wet season, we drop a lot of milk. They don't bring it anymore. Again, the problem with the market, the problem with the prices, and the problem with the delayed payments. So in the same, in parallel, you have the agreements. This was for us our quantitative data to see actually if they will be paid, they will pay us for it or not. So in the Kumu, you see 0 payments. They didn't pay for any agreement. And the problem was here, the management problems. So this is one other challenge that you will have on the field. The people that you are working on, they have their own challenges, they have their own governance problems. So this was very important for us to see also. The second group, the farmers group, who were just created based on this system, for this system, they were paying something at least. So in the first months where they were selling the milk, they had no problem, they gave us the money. And then you have the problems that start. You had here in September, like I showed, in October, they couldn't pay for the system because they couldn't pay their farmers at all. And then you have here the question, what's happening? It is a market problem. It's always very much a market problem. But these discussions that we are having now, and these conclusions, they were based on us being there and asking. So we asked cooperative and we asked the different farmers. But now we wanted to see what do the farmers think about what we do also. What do they think about the solar milk cooling system? And here we will explain to you.
So in order to try and understand why some of these challenges were occurring, we conducted some focus group discussions to bring the farmers together and to experience what they have been experiencing on a collective level. And we found firstly that it's important to understand who the members are in these groups. And we saw that for both Lukumu and Kaptama, there's a considerable proportion of female members. In Lukumu, for example, more than 80% of the participants in the groups were female. So we conducted a discussion with the group, with our two male members, and we wanted to understand what is actually your incentive for joining the SMCs. And in Lukumu, we found that the farmers wanted to reduce their chances of spoilage. Remember, these are farmers that are, these are farmers that have very highly producing cattle, highly producing cows, and they tend to be richer, producing volumes that are much higher than the farmers that we were working with in Kaptama. In Kaptama, there was a relatively gender-balanced group, and we wanted to understand if there were any gender differences in reasons for adopting the SMCs. The men highlighted that their main incentive was the weekly payment when joining these systems, whereas the women identified the reliability of the market, knowing that they would be getting payments every so often according to the agreement. And these two options were very important for the farmers in Kaptama because, as we've seen, they're using local cows with lower volumes of milk, and their dependency is very much on what the market can offer. Whereas in Kaptama, where farmers are much wealthier in relation, their incentive there is how to reduce spoilage and therefore promote quality. But then, why then did the farmers drop out of these systems? So we wanted to understand some of the constraints. And we saw from the farmers in Lupumo that their main disincentive was the delayed payments that Farah had described. These delayed payments, the farmers in Lupumo were able to survive for 2 months without payments. And so we see that there's a little bit of a lag, whereas in Kaptama, the male farmers said that their reason for dropping out was that their cows simply had no milk. And the women would say that they have low volumes of milk from their cows, and what they do produce, they keep for home consumption. So we're seeing here different reasons for dropping out in the two sites. In Lupumo, there are governance-related issues related to the management, as Farah said, and the payment delays, whereas in Kaptama, we're seeing productivity-related issues. So we begin to see just how vulnerable the farmers in Kaptama are to price fluctuations, and we begin to understand some of the differences that the two sites are exhibiting. But we also wanted to know, well, there's a reason for selling your milk in the evening, and what are the profits that the farmers are receiving, and how are they using these profits, and do they differ from one gender to the next? So we found that in Lupumo, the number one use of the monies that were received every month from the SMCs was in the dairy industry, in improving their dairy enterprises by purchasing animal feeds, which are very expensive, especially during the dry season. But the purchase of animal feeds is one of the reasons why the farmers in Lupumo could continue to produce milk during the dry season. We see a difference, though, in the expenditure patterns from the farmers in Kaptama, where the men were more likely to rate the purchase of preventative measures to sustain their existing cattle health, so dips and sprays, for example. These are relatively high costs for them, whereas the women were investing more in precautionary alternative options, such as buying seeds for the upcoming planting season. Seeds cost a lot less than preventative measures that the men were adopting.
Now I want to start to introduce you the first example system, our solar ice maker. So the solar ice maker, it works more or less like a freezer, but as Victor already said, that we produce these ice blocks for milk cooling or also maybe for fish cooling. So ice blocks that you can remove and put somewhere else for cooling. And as I already told you, this one works as a freezer. So we have cooling units inside. This one works with 2 cooling units. So I mean, you cannot see look inside, so that's why I put the picture on the wall. So here we have 3 different chambers, and the way how to use is that you can see here, these are the cooling units or the evaporators of the cooling units. So the things in the freezer that get cold. And due to these chambers, you can see that in the middle chamber, this is the one that is surrounded by 2 cooling units. So here, the ice is produced much faster than in the other chambers. And we calculated, or we found out that with this system, we can produce 23 kilogram ice per day. And that means here in the middle, there is a capacity for 18 kilo. So for sure, this will be produced or will be finished within 24 hours in a sunny day. But if you have a rainy day, so we have also autonomy because of these spare places here in the freezer chamber. That means if there is less sun, so maybe the freezer is not able to produce this 18 kilo within 24 hours. So in this case, then also spare ice packs or spare ice blocks from the side can be used. So that gives us an autonomy of more days. So in rainy days, maybe if you have no sun or if there's less sun. Then, as I already told you, this system, we want to work for 24 hours. So that means, here this is the picture from the back side of the freezer, and this system works with batteries. So for these two cooling units, they consume around 70 watts each. And for these two cooling units, we use two batteries, two 40 ampere hour batteries, and solar batteries. And if you work with batteries, you also need a key component, and this is the one in the middle. This is a charge controller. Charge controller that controls the charging of the batteries, the power supply for the cooling units, and this one is then directly connected, or PV models are directly connected to the charge controller that you can see here. And here then this is connected to the batteries and releases the energy to the cooling units. So the charge controller, if the battery, so it wants to prevent to load the batteries below a charge of 50%, and after, if it's below, then it cuts the connection or the power supply to the consumer, so to the cooling units, to prevent discharging too much. But in our case, we don't want to have this case. Maybe in the night, if the batteries are too low, if the freeze is off, that means that you will lose ice in the morning. And in this case, we have three. So we have a smart control. This is why we call it smart solar ice maker, because we have two efficiency modes, three modes for running. And so during the day, if you have a lot of sun, we have the high power mode. That means the compressors are working at full power at 3,500 RPM. And in this case, all the batteries are charged. In the evening, when there is no PV and the batteries are discharged, then the freezer goes into an efficiency mode. That means the compressors are working at a lower level, lower consumption at 2,000 RPM. And also the temperature is set to -11 instead of -18. And if the batteries are low, close to 50%, then the freezer is set to 0 degrees, fans are off, and we just want to manage that the temperature is at 0 degrees and no ice is going to be melted. And then hopefully the next day there will be enough sun to start again. Yeah, so far for this. And now I want to give to Julian to continue with the second example system.
Yes, thank you very much. I want to present you our battery-free fridge. Here we're aiming at higher temperatures. So this is meant to be for storing food or beverages in this example. We want to achieve temperatures between 4 and 12 degrees. And as the name says, we don't use a battery. We directly connect our cooling unit to the PV modules. And the question is, how do we store the energy? So we're going to store it in a thermal energy storage, and we proceeded with a very simple and very cost-efficient solution. These are ice packs, as you see on the back. We have attached, I think, 41 ice packs to the evaporator plate. They're filled basically with water, with a bit of preservative. And yeah, here you can see the assembly of these. We have in total around 8 kilograms of ice that is able to gap the time that we don't have direct solar energy. This is enough for an autonomy time of 30 hours. This autonomy time is a metric. I don't go into detail, but you're invited to come over and we can talk a bit more. So we also prepared some sodas so that you can get an experience of the crew. Exactly. During the workshop, we were also looking at the construction. Victor, maybe you can go back to the slide. So we discussed how we assemble the unit, how people can maintain. In the case of a failure, you can exchange the unit. And I think this is a very good example how easily the switch can be built with material. In our case, again, this is just an example to show with which kind of material you can build it. Florian later will talk about the functions of each material, and yes, I'm available for further questions in the coffee break. So now we continue with the next example system.
Yeah. Now the third example system is a bit different in the heat transfer and the cooling, how it works. So the thing is, in the two first example systems, we cooled first air to cool then a room down to -20 or to around 4 degrees. So in this system, we put the evaporator directly into a water bath. And now the look inside that you cannot see here is that when you put the evaporator into water, so we are also working with the evaporator at around -10 degrees, then you can see that in the water the ice is drawing around the evaporator plate. And this makes us possible to store solar energy directly into ice. And the aim is not to freeze the water baths completely, so they are around 50 liters of water, to leave some water inside. And that means we can also use that water, or we want to use that water to cool something. And as you can see here, so out of the ice storage, here we can use the water from the bottom that has around 4 degrees, because inside, while freezing and melting, the water has normally around 0 to 4 degrees. So in the bottom, because it has a higher density, it has around 4 degrees, in the top 0 degrees. That means the water that comes out here has around 4 degrees. And here we can use any heat exchanger for using that cold energy. And for the first example, I want to show you a heat exchanger to air. And here we have an air conditioner or a heat exchanger for air cooling. And this you can use, this cold air you can use for a cold room, for example. And cold rooms are necessary for vegetable cooling, fish cooling, or maybe also meat cooling. And how it works is that here we have a heat exchanger directly to air, and then the warm water comes back into the ice storage, and into the ice storage. That you can see here, the water then is distributed over the ice block, and to do so, we can then discharge the ice block, so the water is cooled down again with the ice block, and the same way the ice block is melted. And this is how the ice block or the cold energy can be used and extracted for a cooling demand. And in our case now, this is air cooling. And Victor now wants to show you another assembly for milk cooling.
Thank you, Florian. So as you can see here, we have an ice storage system. It's a water chiller that uses the energy concentrated in ice, produce 25 kilo of ice per day. So this is a huge amount of energy. So this system is also perfect to be used for milk cooling, because as you know, milk needs to be cooled down very quickly in around 2 to 3 hours. So with this system, you can use the energy in the ice to cool down milk. So this system that you see here, this water chiller, is also suitable to cool down 80 liters of milk in 3 hours from 35 degrees to 4 degrees. I would like to let you know a little bit about the scalability, which is actually the advantage of using local production. So let's have a look here. If you use one solar cooling unit, you can construct a whole room of 4 cubic meters, or cool down 80 liters of milk per day. What about if you want to make it bigger? If your cooperative is bigger, your customer needs a bigger system. The other extreme sample will be to use 12 solar cooling units. With that, you can cool down already a 20-feet container to around 15 degrees. Or you can cool down 1,000 liter milk in, for example, a milk tank that is in contact with the cold water of the water chiller.
And yeah, now, as we already said, the systems are scalable, and we also promoted it as do-it-yourself systems. And that means that you can make it themselves, and it also makes it possible to scale them if you make it yourself. And to do so, you need you need to think about 4 crucial points to make them. And this makes you then more flexible while considering these 4 points. So the first thing is to think about the technology, so about our cooling unit here. So you have your cooling demand, and then you can calculate how many cooling units you need for your cooling demand, how big the box should be, or maybe the water chiller should be, or a water bath. And for this, then you can calculate first the technology. So this is the most important thing in the heart of your cooling system. And then you think about the box and the storage systems. And for this one, we want to make sure that you can use any material that just fulfill these 4 points. These 4 points that are important to fulfill the cooling. And the first thing is, as you can see here, they are created more or less the same. And for the outer part, for creating the box, you just need any material that makes it stable. And here we use a wooden box, so this is just painted, but you can also use any other box or any other material like plastic or maybe metal. Then if you work with cooling, so also insulation is very, very important. Here we use polystyrene, but you can also use other materials like maybe straw or just air, but it needs to have an insulation effect and necessary insulation effect. And the last point is for the inner room, it is important to make it waterproof because in the warm areas and also humid areas, and while working with cooling, there is condensing water, and here inside we have a water bath, so it's self-explained that you need to make it waterproof. And here we use acrylic glass plates, and inside of the water chiller stainless steel, but it's up to you what you calculate and consider, just needs to fulfill these criteria. And this is how you can make them yourself.
Yes, thank you, Florian. I now want to continue talking a bit about the last days and give you some impressions and insights about what happened Monday to yesterday. So we did 3 hands-on training days, and we were focusing on different target groups. On Monday, we had a focus on academia, and we had a group of 60 people. On the second day, we focused on companies, also a big group. And on Wednesday, we focused on entrepreneurship. Yesterday, Thursday, we kept flexible to be able to hold bilateral meetings, and I think everybody agrees we were very busy the whole day, and we had around 15 participants as well. We were at the Energy Research Center. As you can see, we had access to PV panels, so we directly connected our example systems to the panels. We had a theoretical part where we were talking about the basics of PV. We looked at all the key components in detail, the cooling unit, as you can see on the left, and also all the parts of the cooling unit. Like you see here, we talked about the example systems in detail. We had a closer look, we disassembled, we showed you how the units can be attached and replaced. Also, we had many ideas from the participants that we were not thinking of, because this number 3 is not at the end. There are many more applications that we actually will learn from all the participants that we have in the training. Yes, here you can see the assembly of the fridge. We also took a closer look to the PV modules. We talked about what is the optimal way of designing the PV system, what's the optimal slope, and so on. We had very great discussions. We had good feedback. A lot of criticism, which is very important for us. And here I want to give my colleagues the opportunity to add something.
Thank you, Julian. I would like to present the solar cooling manuals that we have prepared, that you have also get through a link. In this solar cooling manual, you can find all the steps to assemble the sample systems, and you can also have a look to the dimensions of them. So you have all drawings there, and you have also an insights on the performance that you can expect for each of the sample systems. And from the other side, we have developed also a simple solar cooling design tool that is based on SL. And in this one, you can enter your weather data, your ambient temperature, your solar radiation. As you can see here, you can select which kind of system, which kind of a sample system you want to use, or maybe you have your own design. And based on that sample system and the amount of milk, of ice you need, so depending on your cooling requirements, and depending on your temperatures, and depending the frequency you want to cool down that product, you will get an estimation of the cooling units that you need, and the PV module size, the PV panel size that you will need, and you will get a direct comparison of your system working without batteries or with batteries. You always need to have more cooling units when you don't have batteries, so it depends a lot on the cost of your batteries and the cost of your cooling units. But it's very interesting to see, if you have a look here in the income generation of the system in comparison to the investment cost. This will be the battery system, and this will be the battery-free system. So you see, of course, you have a short payback period if you are using batteries, but as you can see, after a couple of years, because you have to substitute your batteries, you will be at a similar price using batteries or not. So that's why it's quite important that the cooling units we promote can work with or without batteries, because we think this is very interesting. You can find those materials under this link that I think everybody here would have. If not, please ask you to give you this link. There you will find the presentation slides, not only the presentation slides from today, but from the training days, the solar cooling design tool in SL, the construction manual, and if you want to learn more about our ongoing project, our knowledge management, we do with Energypedia. So this is our link where you can find the actual progress on our work and future progress too. Allow you to make some questions regarding the technology, but based on the questions that we got so far, I would like to clarify that we want to promote the local production to 100%, not only the insulation boxes, but also the solar cooling units. But at the same time, we want to enable access to the technology, and that's why we have prepared a solar cooling unit that is available in the market already, that comes already with temperature sensors, with a control unit, with a pay-as-you-go interface. If you need that, you can connect directly to batteries or to PV panels. This is a vapor compression cooling unit. Yeah, and I just wanted to make sure this is the key component that we have brought to the market in cooperation with our distributor, Faisan. We are going to get a presentation soon. But we are, of course, also supporting the local production of those solar cooling units. So if there is any industry partner interested on that, we would like to support that too. And having said that, I'm wondering if there are any questions open regarding the solar cooling unit or the sample system.
Thank you. I was wondering, during the time that the systems were piloted in the field, were there any changes made by the people that were working with them, the farmers and things like that? Did they adapt the technology at all?
Father, do you want to answer that? The question was if in the time we have been on the field, if there were some changes on the way farmers work, right? Or
First thing that we need to clarify that the systems that are on the field, they are not these systems. They are the commercial freezers that you have, the other version, that we imported the whole system to the field. So from that point of view, technically speaking, they didn't change anything. But in Tunis, for example, they used it also to cool meat. So they were putting their dairy, not only cool milk, they were also cooling other stuff. But in Kenya, no. In Kenya there was no change. They were just using it for cooling the milk. But technically speaking, there are no changes.
but maybe on the how the technology is affecting the value chain? Yeah? Yeah, this will be my question.
About?
Because I think it's very interesting what you have been commented. There is not only a change in the technology, but you are affecting also the value chain, right? So have you observed any change on the dynamics of the value chain, if they have access to refrigeration or not?
But I think what we notice is the short food supply, that's what's called, so the chain is no longer that long. So the farmers group, at least, they are feeling more comfortable to send their milk on the market directly, without going through the cooperative. Which is interesting because when they go to the cooperative, they get less money, but they have the liability that they will be paid at some point. It could be that they are paid after 2 months or 3 months when they have problems, but still they are paid. And now because they are sure of their milk, then they just take the shortcut and they sell it directly to the local market because they are sure of the quality. So this we notice, and this is a change in the value chain in general.
Thank you. Do you have other questions?
About the system?
Okay. I've seen in your report when you are doing research on how now milk is produced and being sold to the wholesalers. I saw in your graph that during the wet season there was low selling of milk. But we understand in our country that during wet season there is high production of milk. Now, what were the farmers doing with the milk?
True. In the wet season, you do produce more because you have the heat for sure. But what I showed in the graph is the milk that is collected in the solar cooling. There's a big difference. So the farmer can actually produce 4 liters in the evening, but instead of delivering these 4 liters or 3 liters to the solar milk cooling, he's selling somewhere else. And this is because they have the problem of the prices in the market, because when it's wet season, the wet season, that means you have lots of milk, that means the prices are low. Correct? And when they are selling to the solar, they are getting, let's say, 32 Kenyan shilling. But that is because this is the price of the cooperative or the farmers group. So the farmer, what he does is he goes and sells locally because maybe he can get this extra money. So he can get 35, 36. That's the difference. So the production is there. It's just that there are so many governance problems around also the dairy value chain, especially when it comes to the prices and for the payment and the regulations around it. It's just a little bit critical. That's why there's always this option of me not bringing my milk here because I have problems that you are not paying me. So it doesn't reflect how much they are producing. It reflects how much they will give you and still be capable of waiting their payment. That's the only thing. That's what reflects, I think, the challenges around it.
Thank you for the questions. Are there any other questions in the back? And then we'll go to you.
Yeah, thank you. I just wanted to know about the system, what type of refrigerants they use.
Thank you very much for the question. Actually, we had in the training days on a slide for that. We are using R600A isobutane, which has a global warming potential of 3 in comparison to the R134A, that is the most common used one that has a global warming potential of 1,400. What does it mean for us? As soon as we are promoting the use of solar cooling systems, you have to pay an attention on the refrigerant you are using. If you are using not a natural refrigerant, if you are using R134, which is what you are going to find in most of the systems, then the CO2 emissions that you are saving because you are using PV panels, you are going to destroy all the emissions of the first 7 years as soon as your refrigerant will deplete to the atmosphere. So this is a very important factor. Ozone layer is not relevant for our refrigerants because 134 is not a problem for the ozone layer, but the global warming potential is a problem here, so the industry hasn't changed yet so much into natural refrigerants, but we of course wanted to have a natural refrigerant in our solar cooling units, and this is also a reason why this is an innovation, because when you get into a company, they are used to produce those compressors for other refrigerants, and then you need to start a new development. So this needs also to take into consideration. But solar is good, but once you are working with cooling, you should take put attention also on that.
Did you get the customer feedback in terms of the design of the unit? And what's the capacity of the units that you installed in the field?
Feedback?
Design.
From the customers in the field, you mean? Yeah, I mean, maybe we can talk about the sample of Tunisia. We were in Tunisia with a commercial ice maker. Imagine a commercial ice maker or a commercial refrigerator that we had adapted to work as an ice maker. And then we were there, and many farmers say, I love it, I love the PV panels, I love having ice, okay? But this is not what I need. I would love to have a small milk tank so that I can store my milk 2 days. And we realized there were many young people telling us, why don't you do that? Yeah, bring us a milk tank, then we will save our milk here for 2 days, and then we can get independent from the cooperative, because we are going to save transport and everything. And this was also the first time we realized, okay, yeah, you are there with the technology and it's not adapted. If we have brought these systems already there, I would have told them, no problem, convert it into a water chiller, produce something, use the same cooling units for that, use a water bath, and then put your milk cans there. And they would have been happy. This would have happened in 2 months, they would have been happy. And I think this is a very, very important point, because the adaptation of the technology is quite interesting in terms of business model, because those farmers are working with your technology every day, twice. So it has to be something that is practical for them. It has to be something that is helping them to make a better business. So for some farmers it was okay. For other farmers they said, this is too small, I don't want to work with ice. What I need actually is a system to store my milk for 2 days.
I have the same question for you, because I know that you are also working on solar milk cooling, right? It's correct. And your system is a little bit different from ours, because you put the cans inside of a freezer, correct? Or a cooling unit. So can you explain to us how did you arrive at the design of the system? Do you know?
We were also testing on the units. That's why we took it to depending on the capacity. So most of the farmers prefer the unit that could store milk from about 50 to 100 liters. And then the dairy cows, most of the dairy cows also prefer a bigger chiller, milk chiller that can store about 1,000 to 2,000 liters for daily milk, so that a truck can be sent to collect the milk, and the farmer will end up saving on the transport cost. So that's some of it.
Yeah, interesting, because for us, when we were talking with the farmers also at the beginning, before even putting the system, they said that we will have so much milk in the evening that 40 liters is too low for it. And then when we put it to see, of course, by our eyes and to see how it works, they were not capable of pulling this or bringing these 40 liters on the site. So of course, it's very, very important to get the feedback from the beginning, but I will also say it's very important to check how it's working on the fields and how much they are collecting actually. Because you might have the biggest system that you bring it to them, and the cooperatives around our areas, they have tanks of 500 liters, tanks of 700 liters that are always underutilized. Because this was always the factor that is missing to check what happens on the field.
But also to add a little bit on that, I'm happy that you are mentioning that, because I think you are doing a similar experience that we do. And this is why we have this strategy, because if you have somebody in the field that is able to produce this, then this person can approach the farmers and ask, okay, what are your needs? How much milk do you need? What are the milk cans that you will use? How big are they? Whatever, and then try to adapt to their needs. So if they need 80 liters, then you use one. If they need 160, then you use two. So you have the knowledge as manufacturer, you have the knowledge, you can adapt the technology directly on site, and it is not so costly to approach the different customers with different sizes, because at the end of the day, it's just the insulation box what is changing, or the water bath. And maybe a farmer is actually able to produce a water bath, or has already a water bath, because we know also some farmers cool down the milk with cold water. So it is just trying to share a little bit the value addition to get into business and match the business model of farmers with the business model of a local manufacturer.
Asking, in our systems, I understand you are using vapor compression. Is it? I was asking, is it possible now to use vapor absorption type instead of vapor compression?
Yes, it is possible. There is also some companies approaching these systems, especially if you have access to biogas, then you have heat that you can use to run an absorption system, or you can do that with solar thermal. So it is possible, it is theoretically possible. There are also these cooling units available for that technology. I have seen them also. But I personally believe that the combination of vapor compression and PV is the most efficient one at the moment, and also the one that has the better cost efficiency, and you can also scale it very well. But this is our personal opinion, because we do productive use, so we need the performance. But we are, of course, open for everything. And as I said, this is our key component that you can buy or not. What we want to promote is that the system can be produced locally. It doesn't matter how. Mm-hmm.
I'd like to find out in your field trials, did you come across any experience of maintenance failures on the equipment? And secondly, were there any issues of inappropriate use of the PV panels, i.e. people tapping power from the PV panel to power other things, like TVs or charging phones, and how do you deal with that?
Mm-hmm.
Another observation I made with this system is that you mentioned you had an SD card. I noticed it's somewhere where it's easily accessible. In most of these
Thank you very much for the very nice 3 questions. I start with the last one. We have an SD card and we have also a connection to the smartphone. So the display of your cooling unit is your smartphone. You can have a look what's going on there, if everything is working well, battery voltage, temperatures. So not only the SD card, and I agree with you that SD card might be not so practical for somebody, and not only because of the cost of the SD card, also because you need to take the data out, make upload, whatever. So we are aware of that, and we are working to have an internet connection on them so that we can monitor also the system online, and this might be also an option then for technicians or users to have a look what's happened. The SD card at the moment is very important because you can know what has been happening with your system. So you can know if users have produced 10 kilo ice or 20 per day. You can see if they are using it well or not. So this is very, very, very important. And you had also the question regarding maintenance, but the second question was actually regarding the misuse of the system. So what we do when we are on the field is to make sure that they can charge mobile phones and that they have also lights. Because we didn't want them to start changing connections, so we gave this possibility in advance, and it's working.
Actually, they were not misusing the PVs, they were using them very well because they were using also the shadow of the PV to put the chicken underneath. So that was very interesting also, and it's a perfect place for it. But as of a misuse of the energy, no, because as Victor said, the phone charging is very good and the lights, so this is what they needed. And for the maintenance, we didn't have failures on the fields, so no big failures. What we always ask the farmers is to melt the ice, of course, and the PV they need to be cleaned, so this has been done regularly. We were lucky not to have problems this time at all.
A couple of problems we had, right? In Tunisia.
In Tunisia we had lots of problems.
Yeah.
For sure. But that was because of the technology, sorry. We were just proving the technology at the time.
No, but I want to mention 2 cases in Tunisia, very interesting. And that's why we don't want to go alone anymore into the field. We need local technicians, local manufacturers, and we need local maintenance. So if your question was in this direction, I agree to 150%. We need local maintenance because I'm going to mention you 2 examples. We installed PV module, PV panels in Tunisia, and then 10 days later, the first hurricane ever in the history came to Tunisia. So two systems were destroyed. They were flying the PV modules around, and this is why. And the reason was the customers didn't have prepared what we needed actually to make them fix, and they didn't do that. Yeah, and then this happened. So very important to have somebody around to control that. And I remember also some failures. I mean, they were not very bad at the end because we were there. We were having partners, but this is a project, right? And after, when the project has ended, the project partners are gone, right? We are also gone when the project ends. And I remember very well the problem with the PV connections, because they were moving the PV modules. They decided, okay, not here, my cows are here actually, let's go to the roof or let's go to another place. They were moving the PV panels, and then the connections to the PV panels, you know, they have connectors, right? So they were disconnected, and after a while they called us, hey, your ice maker doesn't work, it's broken. Yeah. And then we sent somebody. Yeah, okay. And then they didn't know what's going on. The batteries are broken, the ice maker is broken. It was a huge confusion. And then you go there, you take a cable and do click, and then one day later the batteries are full again and the compressors start working, the ice maker start working. So those are examples where you see, okay, you need somebody around, yeah? You need somebody that you can call and the next day is there, because in most cases it's nothing, yeah? But those are complex systems. the customers are used that if a fridge doesn't work, it's because the fridge doesn't work. But here, maybe the batteries are the problems of the PV panel. So I don't know if this was yeah. So if there are not other questions, I thank you very much for those, and we'll give back the word to Juliet.
Thank you so much for all your questions, and I think Victor and Far and the rest of the team will be available to keep answering your questions. As we move into the next session for today, which is on agricultural value chains and systems perspectives, we would like to invite a farmer from Kilifi who has actually flown in from Jakarta to talk to us about her experiences with dairy and vegetable farming, and maybe provide some insights on how a cooling system like this could be of use. If you would like to ask her questions, she will be around only for a short while afterwards, so try and catch her. So, welcome. Cacao Fresh Farm is a small farm that's started in 2016 by my family. So that's Kakaungu, and Kakaungu village is located in Kilifi County. It's 15 kilometers away from Kilifi town. The population in Kakaungu village is about 5,000, and people here, the local people depend on fishing for living. They depend on small-scale farming. Also, the women here they cook to make a living, and also they cook to make a living, and also they make fresh juices. So they always need refrigerators to make the ends meet. My family settled in Kakaungu 200 years ago, and they started producing coconut and all this produce. Over there is Kakaungu Fresh Farm. It's about 20 acres. Okay, here is the scene of how Kakaungu. It's about 5,000. The population is about 5,000, and all are welcome. And this is how Kakaungu look like. Here is Kakaungu Dairy Farm. So I started with 6 alpine goats. I traveled to central Kenya, that was last year, and I purchased 6 female alpine goats and 1 male. So now we have 16 goats, and we bottled the milk for local sale, which is not much. It's about maybe 10 to 15 liters, depending on how the feed and the weather, you know. But look here now, we are facing with a lot of problems. See, in fact, the power outage is a lot, high cost of electricity. We have high cost of generation, fuel maintenance. So we have, the problems are more than what we're expecting to get in return. So I'm here today to see how the solar cooling project can be piloted at Kakaungu Fresh, especially if we can use the ice making or the chilling, so we can help out with the Kakaungu village. Also decrease spoilage, improve quality, expand markets, and reduce poverty in Kagamu village. Thank you.
Thank you so much for sharing your experiences. You will be on your way back to Jakarta this evening, so I understand you might not be with us for much longer this morning. So if anybody does have questions, we encourage you to try and catch her before she leaves. But for now, I would like to take the opportunity. I would like to take the opportunity to invite Mr. Tobias Svernen, and he comes from the company Faizan. He has, for about 5 years with his company, had a great cooperation with the University of Hohenheim to commercialize previous innovations. And this company is very interested in the work that Hohenheim is presenting today, and I think Tobias can share a few more words about his interactions with Hohenheim and the work of Faizan. So we are very grateful to have you here with us today.
Thank you very much. The first slide, my name is Tobias Sverner, and I'm representing the company Faizan. We working since very long time together with the University of Hohenheim, and together we developed a milk cooling system. And as the first slide, I introduce you a bit about the company. Our basic motive is independence, so we concentrating 100% on off-grid applications, systems, components, and on one hand, just to show you in the technology of solar, we concentrate in photovoltaics 100% in off-grid in different business areas. And we have two feet on what we stand. It's on one hand solar components, so we are a wholesale company where we get everything which is needed to realize off-grid systems. And on the other hand, we give you also complete developed solutions as a service, the engineering, so you get from us turnkey solutions for off-grid systems. In solar components, we have a bright product range. If you're interested, we have brought a product catalog which looks like this. So if somebody's interested, there are some more. And in the complete solutions, which means solar systems, we work in rural electrification, water systems, and in industrial applications. Just as an introduction of the company. And in these segments, we work in industrial area with oil and gas companies or with telecommunication companies who need power supply for their repeater stations. Or in the water sector, we work in the water pumping, drinking water pumping area, and also in water irrigation for. There's another brochure I brought. This is a EU-funded project which is ongoing at the moment until 2020. It's a consortium of 10 institutes and companies under the lead of Fujifilm. That's a new technology of water desalination. And in rural electrification, we start with Pico PV kits, which we offer. Solar home systems, street lights, all what we need. And what is very important for us is a field which fits well to our company, because we are as wholesaler and as system integrator on the other side. It's very nice to design customized solutions, and there we are in the productive use area. We call it business opportunities with solar systems, and that's the major topic for today. Good. We have these cooling unit, which you have got the presentation already in detail, and it has some major advantages, because as an entrepreneur you have a lot of possibilities to create your own refrigeration system. There is a wide range of possibilities. Since we can use totally different rooms and areas to cool down with this unit. So here are just some examples, but a lot more are possible. And at the end, it's a much smaller space you need for transportation, so it's reducing the transport costs a lot. Otherwise, if you transport cooling boxes with 160 or 200 liters or 300 liters, you transport a lot of air. In past, we have tried to use this air, filling it with other components like charge controllers or like cables or what have you, but the risk to damage the refrigerator box is high, so we stopped this again. Right, bad experience. Good. What is in the cooling unit included is the evaporator, it's the compressor, the condenser and the electronics, which is offering a lot of features which Victor and the group of University of Hohenheim has presented in detail already. This is how it looks like as a complete cooling unit with your self-made box. So you have a solar system, you have a solar module, charge controller, battery, and then the self-made cooling box. Yes, a lot of examples. Good. We have looked about the costs. How much is the cost when it's landed in Kenya? And we have been shocked for the first moment, but we also want to shock you to share with us the price. So we had this discussion. Nevertheless, it will be a healthy shock. The calculation looks like this. So we have on the first row, it's Kenya shilling. If you import 110 pieces, which fits in a 20-full sea freight container, and we have it in euro also, and then in comparison with air freight, when you ship 10 pieces, and it ends up with 1,100, 1,200 euros per item. But there is a lot of space to reduce the price, and this is in these duty import fees, because we have calculated this 25% duty, and we see that we used the wrong customs tariff number, and with the right customs tariff number, which we figured out yesterday, we can even set this 25% to 0. And also in the value that is tax, we have a chance to import that for 0, but that has to be checked first. So there is a potential of 41% less, if not more, if we are going into a higher production volume by reducing the purchase pricing for the raw material. So not too much showing you the prices, because I want to lead your attention to a much more important point. When we opened this conference today, the lady from the Strathmore University said, "Can you remember the first ice cream which you ate?" And that reminded me to a project which we had in 2012 together with the University in Nairobi and the Cooperation University in Abaminch in Ethiopia. And there we developed a lot of solar entrepreneur cases with them. And one was this case, which is a mobile solar ice trailer. So what they did, they brought ice cream to a village which is unelectrified, and they found out a big customer group which never had this experience of ice cream. And this is, I guess, a much more important topic to show that it is a dramatic potential in entrepreneurship in rural areas. And if you see that you offer something totally new to a reasonable price, for sure, then you are monopoly at the same moment, and you can sell a lot, and this gives you an extremely good possibility for income generation. And these entrepreneurs who taking this, so you see what it is a trailer which was produced, it's a solar module on the top and a refrigerator inside, so that trailer can be now produced to a much lower cost with this cooling unit, and has a lot of potential. And if you just think about it, and you are an entrepreneur and you have a business idea, it gives you a lot of possibilities. So this is much more than landing price or retail price. This is a case where you area, generating income for yourself gives you a lot of independence, and you don't have to move from the countryside to the cities and search for a job. And that's what we prefer a lot. Checking how much time is left. See, okay. What we have to recognize is there will be no sustainable development without entrepreneurs. So, based on education, the next step must have been education on business, and to show the people that as an entrepreneur you have a lot of chances to become independent, to generate your income, and this is just based on the right smart idea. And an entrepreneur, because it's always thought about, but where do I get the finance to found my own company? An entrepreneur who has the right idea, he will always find his budget, because he is so convinced about his idea, he is extremely motivated, and then he will find a budget from the family, from the community, he will find his way. And if he doesn't find the big money, then he finds small money. I have only 3 minutes left. He finds his own budget from elsewhere, and that's just what I want to give you. Try thinking about productive fuels, about business opportunities based on solar systems, and just giving you the idea that it has a lot of potential. So that's our target. Happy customers at the end, and that's all. Thank you very much for the attention. You can also say
Thank you so much, Tobias, for sharing your experiences. Would there be any questions for Tobias at this point? I know you're still around during the day, but please.
Yeah, thank you very much, Mr. Ali, for that deep, good appreciation. Do you have any agents in Kenya? We have got 47 county governments, and they need this product badly to create jobs. People are leaving universities, they need jobs. So from that, I think one student of mine is going to create one job now. Now, do you have a dealer, okay, whom I can go to straight and they start buying this, and money start flowing into your account? Do you have any right now? Would you like to give me the contact so that you can start? Some people who don't know there's a good way of making money very represented.
Yeah, so the product I showed is just an example. What we're selling is the cooling device now, and we have a company which is located here in Nairobi. It's called Miranda Limited, and Mr. Fabian Spencer will be around later on.
How many have you sold so far, roughly?
Nothing, because we are just starting. This is the first batch we starting. So we ordered the first 30 pieces, and we are just starting on scratch. It's a very new prototyping what we see here. The first production is just arriving soon.
Any other questions?
Okay, when I saw your mobile ice cream trailer, it led me to ask the question, maybe Victor can answer it. How durable are the cooling units if you mounted them on a vehicle which travels maybe 100 kilometers on a rough road every day? I mean, can they sustain that kind of terrain? Because it's giving me an idea that maybe you could have a mobile refrigeration vehicle.
Yeah. So over the last days, we also got a lot of new ideas as a feedback from the participants. Transportation of the cooling unit is one crucial thing. We have no experience yet, but will need to be tested, and we discussed that also yesterday. What if we need a mobile version of a cooling device, and is it able to stand this rough daily usage. We don't have a solution yet, we have to test it first, but we see a good chance that that can be also implemented in trailers or in lorries or whatever.
Tobias, what's the difference in production costs for the mobile ice cream lorry compared to the conventional one? Because it still gets back to affecting the price of the actual ice cream.
Yeah, I have no idea because this was just a prototype from the University of Hohenheim, from the entrepreneurs from there, and they just made it for their own use. They developed different businesses based on solar power supply, and that was one of them. There have been a lot of others, like computer school or mobile photographer, and I have no idea. This is just to give you an idea, and that has to be well thought through and prepared and to calculate it. Okay. Yeah.
I was going to ask about the tax. You mentioned that it's possible to get duty-free and VAT.
Yeah.
So is that a function of how you classify, or is that a function of how it comes packaged?
I think there are companies who have more experience, like Davis and Shirtlift. We have to ask them how they import the cooling boxes at the moment, if they are tax-free to be imported. I don't have the experience because I'm not from Kenya, but we have seen that there is a good chance to reduce the 25% duty, because we have a totally different customs tariff number with the cooling unit than a ready-made cooling box. So that's what we can say already. It has to be proven still, but there's a good chance.
Chance that you asked that, do you have experience on that from Sun Transfer? Have you imported, I guess, already a couple of solar refrigerators? What is your experience here?
It's a shame I can't answer this with a straight face and I'm Kenyan. The policy on imports have been changing quite randomly over the last 3 years or so. And my experience is more importing solar systems. And what I think is clear right now is if you import solar systems and the battery and the panel, that's clear, straightforward.
This is also an interesting topic which we have been aware. So if you import a solar system, then it's
and a battery. Because the way the policy says,
is it duty free or VAT free?
Both. As long as and on that is clear. The policy says anything that is specialized equipment for production, which is panel, storage, which is battery. That's clear. Okay. What is still a little bit a gray area is appliance.
Yeah.
And how they define appliances.
But you can see that it's a very big topic to get a reduced import price, because these additional costs from stateside, they are quite important, and it's a lot. So it's around 50%.
Yeah. So yeah. That's a big topic as well.
Yeah. Thank you very much for the information.
Great. So hopefully there'll be an opportunity to continue these discussions as the day progresses. But in continuing with the theme for this late morning session, which is on agricultural value chains, we'd like to invite Peter Ajulu from Green Light Planet to talk a little bit about his experiences in commercializing and distributing solar cooling systems. Welcome.
As you've heard, my name is Peter Julu. I'm working for Green Light Planet. And Green Light Planet basically are manufacturers of solar appliances. Those are specifically solar lights. I'll just take you through a brief introduction of the company and the distribution models through which Green Light Planet works with. So we are present in Africa, in almost all the African countries. So I'll just take you through that very briefly, and if there be any question regarding the distribution models, then we can be able to expound further on the same. Yeah, so Green Planet works with a brand called Santi. Most of you who are in the Kenyan market and Africa, to be specific, will converse to the Santi brand from Green Planet. And basically, our mission is similar to most of you who are already in the distribution channel, is to basically power people who are living off the power grid, and also to provide an alternative energy solution to the people and also institutions at large. So, I'll not go through the details, I'll just give a highlight. We are present in 60 countries, and currently we have over 8 million products that have been so far sold in our global markets. We have about 30 million happy users, and we have offloaded carbon emissions, because that's one of the objectives of using solar. We have other modes of energy that are harmful to the environment, and I believe all of us are gearing towards a vision of downloading carbon emissions in the environment. So we've offloaded over 1.5 carbon emissions. Then we have people we are also empowering in terms of enterprise development. So currently over 3,000 independent direct sales agents are out there in the field selling some key products. And we also work a lot through partnerships. So we cannot do this all by ourselves. We work closely with partnerships who have different modes of reaching out to the end user. And one of our strongest channels is MFIs. On our bigger products, we have a challenge of consumer financing. So MFIs come in strongly to bridge that gap, where consumers don't have upfront funds to be able to purchase the products. We engage the MFIs to come and bridge that gap for us. And then we have also supported other micro-entrepreneurs who are independent by giving them an opportunity to earn a living and support their families through the sale of our products. I'll also quickly take you through what Green Planet portfolio consists of. So we have the very small products, which we call the Pico, up to home systems. And they range in usability and also portability. So for the portable lanterns, we have about 4 or 5 of them, the Pico, the Charge, the Pro 200, Pro 400, and the Boom. So they have different functionalities which I will not necessarily go through due to constraints of time. But again, if you're much interested in knowing further what each one of these lanterns is able to provide the user with, we can have that discussion during the next break. Then we have a series of our home systems. Basically, this will be able to power 2, 3, or 4 rooms, depending on the needs of the user. And we also recently launched Sun Solar TV, because the users or the consumers' needs energy ladder is growing. So today we are using, we are supplying them with lanterns. Tomorrow they need TVs, fans, and today they need cooling systems. So we're also interested to know how do we bridge that gap beyond what we are currently providing them with. Then, as I mentioned, we work a lot with the MFIs, but that's not enough for us to bridge the consumer gap in terms of being capable of buying these products. We also have a model, the pay-go model, for those who want to pay a deposit and pay small subsequent installments towards owning the product. We have an in-house built system or channel which is called Easy Buy. So for the bigger units, we prefer selling them through the Easy Buy model, which is easy for the consumer to be able to get to own the product. Then we have partnered with, I've mentioned we partner quite a lot with various MFIs and other institutions, but some of the strongest partners we are currently working with, one of them is One Acre Fund. This is an organization that deals with farmers, domestic farmers, whereby they come in groups and are able to consolidate their funds for them to get loans. And the loans can be product loans, or they can be farm input loans with a top-up of an energy product. So it's quite a huge network for us. We also have Olu, we have Ekaya brands, Fullerton in India, Total, SKS, and Microcred. So all these MFIs have different strengths, they have different models through which they do their distribution. So we are open towards getting more partners on board in terms of people who can distribute the products. And just to deviate from what Green Planet is doing, I myself have been working with Green Planet for the last 5 years, but now I've started my own distribution network, that is Brightbet. So I'm working closely with financial services associations in the eastern markets of Kenya, that is Machakos. We have Makueni County, we have Kitui County. So how the model works is that all these financial service associations have formed groups of people. These groups normally meet from time to time, and the distributor basically is meant to work closely with the groups. You are meant to introduce the products you're working with, sell the value to them, and basically extend some credit to these particular groups for them to be able to own the products. The experience that is there is the lighting is providing a good solution for them, but again, a lot of questions are there. How do you get us something to be able to store our produce in terms of if it is dairy products? How can we be able to get some domestic cooling system for households? So again, for the people who will be becoming agents for these particular products, we will also be very interested in partnering and seeing how best we can be able to channel the distribution efforts to ensure that the people on the target market is being reached and is being serviced at the right time and at the right price. So I think that is a very brief summary of what we are doing, and I'll allow for questions. Thank you very much.
We have some time for questions. Are there any questions?
Okay, so it's not really a question. I just want to encourage those that are willing to partner with you. Back home, we're actually selling Sun products with the company I'm working for, and they're very good products. We are really beating the competition. It so happens that when our competitors sell their products to the locals, and we happen to go there, they want to take back their products so they can buy ours. And it's bringing a bit of confusion, which is good for business. It's good confusion. Thank you.
Thank you for that. There's a question here.
What mechanism do you have for repairs and servicing? Because we've tried a project where we were trying to empower communities to sell solar lamps at the coast, and it failed because the solar lamps, it's like within a year or two, they stop working, and they said, yeah, you can send them for free, we'll repair and send back, but it just collapsed. And these were like maybe over 5,000 lamps that we at the pilot.
Okay, I'll specifically talk about Green Planet. We have a return policy and a warrant management process. All our products come with a 2-year warranty, such that if there is any fault in the product, the distribution point, if I was to come in and sell to you as Brightbet, that honors lies with myself to ensure that I take back the faulty products and we are able to either replace or do repairs. In addition to that, we have set up satellite shops in each and every major town. So we have some keep-on shops whereby if your consumers have an issue, they should be able to reach out to the shop managers, return the product if it is still within warranty, and have that sorted out. But again, I can have a one-on-one discussion with you just to understand which particular, if it is Sunking, I can be able to assist further to ensure that you are sorted out. If it is another brand, I cannot speak on behalf of the brands which are not here. But for Sunking specifically, we have a warranty process in place.
We have time for one more question.
Okay, I just want to get a clarification from you. You mentioned that there's been a challenge put to you regarding the cooling units, and certainly with such kind of forums and workshops, certainly there are going to be agents to bring such kind of systems. But now my question is, we are going to get the solar cooling units as a unit, but then for the assembly of the other stuff, that's upon us not to be doing it. And for a company like yours that is really much interested in it, it was brought to our attention regarding the issue of stability, insulation, and waterproof regarding the particular equipment they use. I was here for the Tuesday workshop, and I understand they use, for instance, for insulation they use polystyrene plates, and for the waterproof they use acrylic glass plates. So I want to ask you, what alternative materials to look into the insulation and waterproof while assembling these units is your company focusing on, particularly within our local market? What alternatives for these materials are you going to focus on? Will you shed some more light on that to ensure that our food is secure and everything?
Okay, I'll look at the entire model as a three-part kind of a model, whereby we have the units being shipped from Germany, that will be the point of manufacturing, into Kenya. Then we'll have an agent who is going to do the assembling and putting together the product. For us as Green Planet, we come in at the point of distribution. We distribute products that have already been assembled, have been tested, and we'll only request perhaps for training of our technicians when we have issues with warranty. But ourselves, we don't specialize in assembling of the product, so that will not be our role. Our role will be to get them to the end consumer when the unit is completely finished or fully assembled. So that we will not play in the space of trying to assemble the product. We are distributing. That's where our strength lies. Maybe the last question? I don't know if that will be allowed.
Yeah, thank you very much, Kingston. You have a lot in common. You are a member of Korea. Congratulations. Now, my question, do you have allow interns? Intern means somebody who comes to learn on the job. You allow, and if you allow, I have my student here, they graduated in August. So do you allow such things? Your regulations allow interns, people to learn on the job, assignment, projects. You allow interns in your company. Thank you.
Yes, we do allow interns in specific departments.
How many?
I cannot give conclusive feedback on that. We have various heads of various departments, and again, we'd like to know internship will be requested for which particular department. So we can also have a discussion thereafter. I can give you the contacts and also refer you to the appropriate person to speak with in terms of internship. Thank you very much for your audience.
Okay, thank you so much, Peter, for opening up a discussion on commercialization, distribution, what sorts of strategies and models to use to reach users. I would like to invite Alexandra Amrain from the GIZ in Zambia offices, and she is with the Overall Heroes, and she will talk to us a little bit about this innovative initiative that focuses on vocational training. So we look forward very much to hearing what you have to tell us.
Good morning, I like that. I came with the heroes, yeah. Very true.
Hello everyone, my name is Alexandra, I work for GIZ. And actually everything that, how we connect with the other participants from Zambia is more towards the future. So for today I will give you a very brief overview of where we stand and why we're here and where we see the potential, and then I'll pass over to my colleague. So the project I'm associated to is the Community Innovation Centers for the Agriculture and Food Sector. We work on value chains with small-scale farmers. Dairy value chain is one of three. We also work on the soybean and groundnut value chain. We heard a bit about the dairy sector already from Tunisia and from Kenya, and the Zambian dairy sector again is very different. More comparable to Kenya than to Tunisia, and probably more comparable to the one case Katama. So in Zambia we at the moment have the transition from beef farming to dairy farming. Having cattle is very traditional, but being a dairy farmer is the innovation. This is also sometimes where the problems lie, because we have established habits that come from the beef sector, and now switching those habits to the dairy sector behavior change in humans often is very slow, and so this is sometimes where we struggle with. We have about 300,000 small-scale farmers. Not all of them are dairy farmers with dairy animals. Often we have farmers who milk their local breeds. We work together with 15,000 dairy farmers who have normally crossbreeds in the two major production areas of dairy in Zambia, which is the Copper Belt and the Southern Province, and GIZ works in the Southern Province. We also struggle with the huge variability between the production volumes in the wet season and the dry season. The climate in Zambia is very pronounced in these seasons, and due to a non-year-round feeding regime, we observe a large drop in the dairy the milk yields in the dry season. So we support farmers in producing fodder, making sure you have an appropriate feeding regime in place, making sure that there's enough water available for the cows, and slowly bridging that gap. The milk collection centres are usually run by cooperatives. The cooperatives have a very important stake in this entire chain because they bulk, and this is also in our case where the cooling starts. Non-appropriate cooling is a big problem for us, and also economically. There's some numbers, estimations from the Dairy Association of Zambia, so we have to take them with a pinch of salt, but they still give a good indication. They estimate about 445 million litres of milk produced per year, of which 50% is lost due to spoilage. Either because we don't have enough collection centres, or we have not an adequate cold chain, which means that milk goes bad, because normally we start off with a very high bacteria count already due to not the best hygiene standards on the farm. They also calculated that 200 MCCs are missing. So now we're going to have a very brief look at the value chain. So we have our input suppliers, input and service suppliers. We have our dairy farms produce fresh milk or sour milk when it's gone bad. Often also the afternoon milk is being converted into sour milk. The fresh milk is delivered to the cooperatives, and this is where we have the cooling taking place. Normally, however, we have power outages, we have maintenance problems with the cooling tanks, so not even there, although the equipment is there installed at the MCCs. We can't guarantee that the cooling chain is always running perfectly. And then we have the cold chain starting from the cooperatives onwards to the former market, which is dominated by Parmalat and a smaller company, Faroon. And uncooled milk is being supplied to the informal market. So we've been here for the last 3 days. We participated in the training, discussions. We had some good group discussions amongst us. We will first make sure we understand our context, not to repeat mistakes that we already have learned from the Tunisia and Kenya case. Make sure to understand where the business case lies, what would be the most appropriate product for our farmers to use. And however, in the beginning, and actually we only learned about this technology end of January, so we were quite inspired by this when we saw it and pulled together, mobilized a group of actors of 6. We have 2 people from the private sector and the training center on board here, because we understand that we as GIZ, we won't move anything. So if this should have a chance, we have to come up with a systematic and combined approach from different actors, private sector led, together also, because as this is a DIY kit, we need people on the ground who are able to assemble it, who are able to provide the maintenance. That's why in the beginning we pulled in the training center and encouraged the private sector engagement. However, we as donor implementing NGOs have to also be very careful to maneuver carefully in this developing market, because it's a very fragile environment at the moment, and we have to think carefully about our next steps in order not to destroy the market, which we've seen in other products when donor agencies move too fast at a scale that sets the wrong incentives for the markets and then inhibits a natural long-term growth. That's my concern and my kind of pledge from looking also at my own organization. And now I'd like to pass to Sven Buchholz, who will present you a bit of their patient training approach, where we will build up upon if the feasibility study shows promising results for that technology.
Good morning again. I cannot talk too much about solar at the moment. The reason why I'm here with my colleagues is because we're just setting up a solar academy in Zambia. And that's how we come in, because there needs to be some training for these kind of assembly. There needs to be a backstopping, there needs to be second level support. We would like to do that with our private industry partners, and because we are a training center, we do vocational training. That's the only thing I can really talk about. That's why I'm doing this now. Who we are? We are the Association of Building and Civil Engineering Contractors in Zambia. Then we are partnering with the Chamber of Skillcraft in Frankfurt and with the Sompa Construction Training Center, we're calling it which is a government school. We do dual vocational training, so the idea is to bring industry back into the whole training, and with that rising qualities. What we do is we train electricians and bricklayers. Now, I'm here because we do electricians, and I said we do the Solar Academy, and with that we're building a new campus, which will be then under the management of industry, which gives us a whole new leverage on bringing the whole training to the next level. Now that's what I'm doing now. I'm going to explain to you quickly how we think about vocational training. I can tell that from the Zambian perspective, Zambian industry perspective. I would like to know later if you can get away from solar for a second, how you do it in your countries. So first of all, Tibet and poverty alleviation is not the same. That is sometimes a big problem, because everybody says, we do Tibet and we teach someone a skill, then they can go somewhere with their skill and then they have some money they can earn with. That is fine, you can do that. But if you want to have skilled labor force for industry, you can bring an next job and that you don't need to call an expatriate every time you have a problem, then that's a totally different approach. We're doing number two. Then the second thing is that if you get a certificate, that doesn't mean that you have the ability. We have 2 minutes, no? Okay. Yeah, then I think this is self-explanatory. Vocational training output and industry input, the demand is not the same. That is quite common very often that these two don't match. But also, industry demand and actual industry demand also doesn't match. Industry is not in vocational training, so they don't really know what they can expect from a system. And that's why they basically bring a lot of noise to those who are creating these systems. And that's why they, again, don't match. And it took us a long time for us to conclude on that one. So this is how we do it. There is a hierarchy of skills. I don't go into details, but it really goes from very low up to really mastery, okay? And normally what is happening is that industry demand is somewhere up there. I want someone who's perfect, we put them in and he solves all our problems, right? But the actual demand in the Zambian context is down there. Because right now the system is not even delivering people that can do the simplest job, that they're not even ready to get that training in the companies, all right? Because all the companies are training in-house anyways. Even if they say they're not doing it, they're doing it because they're not coming from the system. So our approach is what we call as industry simulation. In short, is to say like, look, we're not looking to solve all the problems of the world. Let's prepare the young people over the 2 years of our craft certificate training to have a solid foundation on which you can build, which includes not that they can do some fancy-smancy special technician stuff, but that they know the simple things, they show in time, we dress properly, have the right attitude on the basis, that they know the procedures in the workplace, when they know the basics of their trade. All right? Jump that. This is how we do it. The craft certificate, we use the normal curriculum is a 2-year, but every year in the term, 3 terms per year, they have a 1-month term break. If you don't want to prepare people for the real life, then that's exactly what you do. You give them 3 months or 40 days a year. I mean, really. So what we do is we attach them to companies. So during the term break, so we're not disturbing any regular curriculum. We're just going with the flow. And then after the 2 years, we attach them for another half a year in the same company. Now what is happening? After the 2 years, they do their normal Tibetan certificate. That is what you have to have, but it's worth nothing. And then after the half year, we do an industry assessment and an endorsement. That now means whatever is on that paper, we're telling you what the guy can really do. Now they have 2 papers, and now the certificate again is worth something. How to make vocational training attractive, that is a really fun part where I will show you some videos that we produce with music, like real African stuff, but my time is up, so maybe another time. Thank you very much.
Thank you so much, Alexandra and Sven, for opening up the thought process into what the role of the donors are, and also the important role of training and capacity building, something that we've been discussing a bit this morning. We are running a little bit out of time, but if there are some pressing questions for Alexandra and Sven, please feel free to raise your hand.
Thank you, Alexandra, for that good brief but very detailed. I think we are having the same challenges in Kenya. We have got Tibetan authority, and people don't like listening because it's low, it's dirty. So I think we have to see you, we talk discuss, because we have to job creation is based on all those dirty work and all those low income. So that jobs come from. I think I'll see you later and we see how we can share. Now, will it be possible to share this communication? That's from the chair. Will we get this film, these presentations? I appreciate it. Thank you. I'll see you later.
Thank you very much for the presentation. I had a question for Alexandra. One of the slides in the presentation was that there are 200 missing MCC. What does that mean? How are they missing? In this context, what
This is an estimation from the Dairy Association of Zambia, based on the milk production and the amount of milk that is spoiled due to the lack of collection centers. A combination, the lack of collection centers and the inadequate cooling chain. But I just wanted to show that there is a market, there is potential to develop new MCCs.
Development. Occasionally, he is going to tell us a little bit more about their work in Turkana as an NGO. And then we shall resume with from class afterwards.
All right. Good afternoon, everyone. I'm glad Juliet said the name, so I don't need to. You can read that. So basically, as Juliet said, we're working in Turkana, and our focus is really the marginalized areas in Kenya to begin with, but hopefully expanding elsewhere. So I don't need to talk too much about the challenge of energy poverty. I think this is quite well understood. But I think what we do need to emphasize is even when people get access to electricity, that doesn't necessarily mean immediate beneficial impacts on their livelihood, even on things like education. So I think analyzing the relationship between access and improvements is quite important. So how can energy have an impact? We think that productive uses are key to making sure that energy allows people to achieve whatever they aspire to and overcome whichever challenges they're currently facing. But in order to have productive uses widely implemented and sort of available to lots of people, you need to have competitive supply chains and any financing that you require to be able to access any products that are being provided. The appropriate technologies for generation and consumption, and I think this is so key to not just using a regular fridge with an inverter and going through all of those steps. There's major inefficiency there. So how can we innovate and develop new technologies that are suitable? And then also adequate technical expertise. We've had a lot of discussion about the need for technicians, about the need for maintenance, even of the small systems of solar lights and things like that. And then the good thing is that in addition to the innovative businesses that come out of this, the new business models, and the subsequent income generation, you then get improved solar services in other areas. So because you have income to support a body of technicians, you then have those technicians who can work on the solar home systems. They can fix, for instance, they can plug in the milk solar system if it's unplugged. They can work on a school or a clinic, all of those community institutions, which also have solar systems. It supports the whole solar network. In addition to that, there's increased connectivity, and especially in Kenya, that means more access to M-Pesa, financing, things like that. So unfortunately, my pictures didn't load, but our main research partner, and the reason that SOSED exists, is the Turkana Basin Institute in Turkana, northern Kenya. And TBI was established really to study prehistory. But when you have a research center in a place like Turkana, you need to be able to provide energy, water, sanitation, and food. So simply because of the conditions, TBI has had to look into, there's a shame the pictures aren't there because they've got beautiful hydroponics with lovely lettuces, and in a space maybe about the size of the stage, they've got 1.5 tons of kale, terere, and other vegetables in 1 year. So our question is now, how can we take that expertise and other expertise being developed and create the business models that allow more people to access those technologies? So we're focusing in on quite a small area. The context is 3 villages with a rough population of 5,000 people, but the wider area has about 50,000 people. There's obviously lots of solar power, but very high temperatures, and not very much rainfall at all. There is the Tapua River and there's groundwater. But our key activities are to develop pilot projects. So as Alessandra was saying, that donors and NGOs should be very sensitive about how they impact the market. What we aim to do is to see opportunities, take on the risk ourselves, and once we find things that are successful, disseminate that information and allow other people to take the business on through financing and basically completely independently and completely commercially develop that enterprise. So in addition to the pilot projects, we do capacity building, and that's not just sort of the T1, T2, T3 very formal training. We're also looking at how can you take somebody who only finished primary and get them more of a solar sensitization so that they understand the basics of the system without having to be able to install it. Part of the reason for doing that is because when you give people certification, it's a wonderful thing, but it's not necessarily a wonderful thing for the community that they're from, because you can't force them to stay in the place that they're from. They'll go, in this case, to Lodwa or to Kitale, further around, and they won't be there to fix the system. So we're a very new organization. We haven't done our first pilot yet, but we've spent the last few years doing research. There's been lots of talk about how context is so important. So understanding what the opportunities are, what the local solar use is, how many systems are there, what are they used for. Music is a big one that we weren't expecting. And then identifying what productive use opportunities there are. So our first pilot is actually going to be on clothing production, because that was one thing people kept on saying, that quality and price of clothing is just not acceptable. And so we're going to be innovating with DC motors on sewing machines and setting up a hub to produce clothing for the local market. So that's for adults, but also school uniforms for kids, things like that. And then that's going to be training local people. And then once we've fine-tuned the technology and we've got partners to sort of get people funding so they can purchase the machines themselves, then they'll go out and set up their own businesses and sort of using the business model that we've developed to make sure it works. But that's the information, the dissemination part. And then the capacity building that I've discussed, not in the correct order, but as you can see, it's sort of getting people to understand what the opportunities are. So not everyone knows that you can buy a Sun King solar home system and pay a little bit at a time. That's not necessarily common knowledge in the places that we're working. But then also what the other opportunities are. Sort of, is a solar pumping system sort of 10,000, 100,000, a million shillings? Sort of getting people to understand and sort of giving that information to them so that they can draw their own conclusions of what they want to invest in. So how does this apply to the agricultural value chain? There's lots of opportunities in Turkana. There's lots of goats and camels and sheep for milk and meat. One reason why we haven't gone into this as our initial pilot is the seasonality that has been discussed. And in Turkana particularly, there's been so many different projects that if you go in as an NGO, everyone says, no, just don't waste our time. So what we want to do is have one pilot that works year-round that we can then tap other things onto, and we can start small with these less reliable and less predictable uses. There's also potential for lots of irrigated agriculture. As you can see there, that's a small farm that was built next to TBI using river water, but it had issues in terms of local politics, cooperatives. So how do we create business models that perhaps sort of adapted to those social conditions? So that would be something that we would look at. And then in addition, something that I haven't put up here, the cooling, there's also lots of opportunity for desalination using temperature difference. So in a place like Turkana where it's very hot, then having the cooling is sort of very valuable because it increases the efficiency of those systems massively. So that's something else to look at in the future. So as I said, we're quite a new organization and we're looking for partners. So if anyone would like to get in touch, we'd be very happy to hear from you. But I'll take questions now.
Any questions? We can take the opportunity to maybe catch you a little bit later when we've thought about what could happen in Turkana. And
since nobody was having a question, I have a personal question. What is your motivation to start this? Where do you come from? Not you, but your vision and your ideas. What is your
So, Turkana is a very interesting place where there's lots of resources, but because of issues such as transport, it's quite far away from the rest of the country and the road network isn't very good. Before devolution, when the constitution changed, there was minimal investment in the region. And now there's more investment, but not as much as there should be in things like schools and such. So it's just like sort of thinking about, given the resources, both human and natural resources that there are, and the markets that there are there, how can people be given the tools and how can we develop those tools further to enable people to sort of create livelihoods there rather than trying to go somewhere else or sort of fall back on pastoralism, which is really one of the main options.
Thank you very much, because I think this is what makes you special, right? That you are actually there in the regions you want to do also your pilots, right? So you know the conditions very well. Thank you.
And I'm happy to join you this afternoon to talk about our experiences implementing
efficiency for access. So as I mentioned earlier, class work aims to improve the energy and environmental performance of our everyday use appliances and equipment, and in such a way as to accelerate to our sustainable world. And we have about 20 years experience implementing energy efficiency programs, which broadly fall into two pockets: the policy and analysis work, which mainly focuses on on-grid appliances, and on market development and innovation work, which focuses on off-grid appliances. So the Efficiency for Access is a coalition that promotes energy efficiency as catalyst for global efforts at clean energy access. Right, so from a recent study that we conducted at the Efficiency for Access Coalition, it forecasted a very huge market potential for off-grid refrigerator products. For example, the market for refrigerator is expected to grow from $76 million in 2015 with a potential for $1,081 million by 2020. However, there still needs to be a lot of work that needs to be done to improve the energy efficiency as well as address affordability of these products for off-grid consumers. So in partnership with Energy Access Practitioners Network, we surveyed energy access professionals to mainly assess the demand and the impact potential of off-grid appliances for household, productive use, and health applications. And from the results, we can clearly see that there's a huge demand for cooling for the household use as well, and it even gets larger on the productive use as refrigerators and freezers rank second. The impact potential for both these applications also ranks high. So yeah. So we also, under one of our program partners, under the Efficiency for Access Coalition called the Globally Powered, we tested refrigerator products in a lab, just basically so that we could understand the technical performance of these products in a controlled and standardized environment. Following this, we shipped these products to Uganda and put them in the hands of local consumers. And the purpose for this was so that we could be able to understand what were the real-world behavior of these products and the impact that they had on the consumers. So what was we observed first, or what was obvious, was that the benefits of owning a refrigerator product goes beyond the obvious income generation. And for example, Proscovia, who's from Uganda, uses earnings from her refrigerator products to buy books for her children. So in partnership with the Acumen Lean Data team, we also conducted phone interview surveys for customers that procured incentivized eligible globally off-grid refrigerator products. And from these surveys, what we learned is that a lot of fridges are being bought for businesses. And also that affordability still remains a very important thing, because 100% of those interviewed bought their products on credit. So another interesting thing is that 15% of the consumers started a new business line as a result of owning a fridge, which speaks to a direct relationship between refrigerators and productive use. So allow me to talk about the funds as well. So we did a survey in Bangladesh for retailers selling fund products. And what we discovered was that quality is a very important decision point for consumers when making a decision to buy a fund, as well as warranty and brand. And so this means that consumers do want products that actually deliver the service that they're looking for. As I mentioned earlier, from the field testing that we did in Uganda, we observed that 88% of refrigerators tested 88% of the refrigerators tested consumed more energy in the field than in the lab. So while this is to be expected, the deltas in some of these data were very big, and so this points to a need for more research to understand what consumer behavior is driving this, and also how can manufacturers best design their products in such a way that they meet and deliver these consumer needs. Because if this is not addressed, there's a potential to damage the reputation of the industry where products being produced are not actually meeting the consumer, the services needs that offering consumers need. So generally, owning refrigerator products have very great impacts for consumers, but yeah, there's still a lot of work that needs to be done to grow this market. So, so understanding that the market for farm products is still not yet mature, and also that for refrigerator, the market for refrigerator products is still very nascent. So the efficiency for access is looking to address this through two main specific intervention points, and one of them is to reduce poor quality products as a way of increasing consumer confidence. And so we are doing this by running, for example, a global leap competition, which is meant to identify top performing off-grid products, developing test method to test for quality and things like that, as well as conducting field trials, which will, as you have seen, will produce a lot of helpful information that can be beneficial for both manufacturers and the consumers. So our second intervention point looks at ways to increase affordability of these efficient appliances, and we are doing this by pairing the global leap competition with the results-based financing as a way of encouraging bulk purchases of these efficient products. We are also doing market segmentation research just to understand what are the different use cases for refrigerators, how big are these different segments, and which of these are most ready to scale. On top of that, we are building technology roadmap, and we'll be announcing grants, R&D grants very soon, and also doing market, consumer, and impacts research. So that is us. And if you would need more information about the partners or resources for efficiency for access, then you're welcome to visit the website at efficiencyforaccess.org. Thank you so much.
Thank you so much, Ruth, for sharing the work and the promotion and the research of CLASP. Are there any questions for Ruth from the break?
Hi everyone, my name is Naya and I work with Ruth, so I don't have a question for her, I just have one other thing to add on what she said. We recently launched the Off-Grid Cold Chain Challenge, and this is primarily focused on identifying some technologies for cold chain for fruit and veg, dairy, and milk production. And we're in the second stage where we have installed remote monitors. So there are 7 technologies around Africa. We've installed remote monitors in them to measure the technical information, but we'll also be producing case studies about the different types of business models. So this information will be disseminated publicly. We should be done around June timeframe. So please keep in touch with the Efficiency for Access Coalition website, and if you'd like to get on our newsletter so you get the information directly, please also drop us your business card.
I have a question about one of your slides where you were showing that mostly all the people that you questioned about the refrigerators, they have problems. And in the graph you have the different problems that they had, and the first one was the batteries. Can you tell us what were the problems with the batteries? Yes.
So some of the issues with the battery was that the power supply. So I think for this will speak to like the expectation of the consumers in terms of like the length of the time that their products are being supplied by energy by the batteries. So it was not as maybe as stated. Yeah.
Thanks. I also work with Ruth. There's quite a lot of us in the room. So I just wanted to drill down a bit deeper on this with the batteries. The question we asked them is, are you experiencing any challenge with the refrigerator? And then we leave that as an open-ended question. So when you ask the consumer that, it's very difficult to always draw out the cheap technical issue, right? So they could mention a battery, but that could just be what they think is wrong, is the battery. But we have no idea. So this is actually a bit that we want to drill a bit deeper and see what it technically means. And self-reporting always has a margin of error. So that's what that's about. But yeah, feel free to speak to us about any of this detail. And where we can share the data, we're also really happy to do that.
Thank you. So I just wanted I saw in the previous graphs summary of, yes, this one, that there is also the air conditioning units. I don't know if you've done a bit of research on it, if this solar cooling can be done. But I'm thinking corporately about like in big units that can be used for cooling, air cooling in houses or big warehouses, things like that. Thank you.
Sorry, I didn't get your question. You're asking if we've done research on?
Solar cooling for air conditioning. Solar, how to use the solar cooling or the solar panels for air conditioning for the bigger units. Because now what I've seen is we're talking about the fridges, the lights. Because I'm not concerned about the big units.
Maybe how can I would like to speak to that?
So we haven't done any direct research that shows whether we can use solar panels to power air conditioning units. Our work there mostly focuses on reducing the energy consumption of air conditioning units. So in that we are in a program called the Kigali Cooling Efficiency Program. A bunch of African governments or actors really are thinking about how to reduce usage of refrigerants that aren't natural. And one of the ways is to increase efficiency of air conditioning units. So our work on air conditioning is really focused on on-grid and reducing efficiency, and not so much on the off-grid potential, right? There we focus more on fans, so the ceiling fans or table fans that can be used within a household.
question is that why have you not done a survey in Nigeria, being the largest, the giant of Africa, and most, let me say 99% of people living in Nigeria, they live on perishable foods, and so there's a high demand for refrigerators, and I think that doing a survey on solar power refrigerators in Nigeria would really be a good idea, because when I see from the slide, you only brought out surveys from Kenya, Tanzania, and Gambia, Uganda. So why have you not done a survey on that?
Yeah, so the survey results here are restricted to the East African country because that is where the focus, those are the target countries for the program. But we actually, based on the competition that Naya, my colleague, has just talked about, we do have some Nigerian companies who are now participating in the Off-Grid Cold Chain Challenge and are actually participating as a way to actually address the problems that you have pointed out. But we hope in the future we'll have programs that extend to West Africa.
Thank you so much, Ruth and Peter, for your presentations. It's great that there are so many questions. And it's been a good opportunity to learn about the different actors along the value chain and the different stakeholders.
Topic. We have talked also from the public sector about not destroying the market through public interventions. So I would like to ask you if you think that local production of solar cooling systems, and in special the technologies we have presented you today, if this can contribute somehow to bring the demand to manufacturers closer together so that the requirements can match better, and at the same time contribute also with training, because when you get involved in the design of a product or in the production of a product, you automatically get trained, and also for the business perspectives. I think it was mentioned during your discussions that without a business or without a perspective, it is difficult to keep a training, right? I think you mentioned that if you don't bring a product, it's difficult to train somebody because you never know when the product will get there. Actually, the same happens with technicians. You can train thousands of technicians on solar cooling, but if no products are getting into there, then it's not going to help. So my question is, do you think the approach we have brought today could contribute? And if yes, I would like to ask you which will be your advices how we could progress and move forward to contribute on the promotion on solar cooling at the end. Who wants to be first?
Okay, I think for the local production, as I said, I started assembling solar systems in Zambia about 3-4 years ago. And I don't think I save a lot of money. But if we're talking here about locally value addition, we have created local jobs. We have gained a lot of skills and become a lot more flexible about trying how to, what the options are about finding a solution yourself instead of relying on a Chinese product because you want it to be cheap, or a German product because you want it to be good. I think the local value addition is the key to local business issues here. So even though it's not straight away an economic incentive necessarily, there are some, but also locally things are a bit more expensive if you produce in smaller scale and stuff. So that cancels each other out a bit, but the local value addition is definitely more than just the cost saving. That would be one point. On On the other hand, we've also experienced that local production is not suitable at all levels if you want to have quality control. And quality control is one of the major issues if you talk about rural solutions. Because a loose connection can ruin, it can have a system malfunction, and people try to repair something cheap before they call a technician. So you need to have a certain kind of buffer built in. Therefore, I think if you look at your approach, I would strongly recommend having a first phase where you have do-it-yourself with production partners, and a second phase where you can say maybe once you have something streamlined and you have one or two products and a proper do-it-yourself scheme, that you can maybe roll out to a more local level and say, okay, those you can even make in a more rural location. But if you go down too fast, I think you'll find a lot of quality issues which will kill a project like this.
Thank you. When you're asking for advice, I feel a little bit outpaced. I think everyone's learned so much in the last few days, so thank you for that. But I think this has been said quite a few times, but in terms of what can be done across all of these different questions is partnerships. So whether it's partnerships with industry for production and dissemination, or whether it's partnership with NGO for research and field testing, I think that's the best way to make use of everybody's resources and to make the best use of the technology and sort of to improve it further.
So, I'm skeptical if local production is the right way, because it needs a lot of knowledge and proper supply of components. And if it comes to electronics, it needs also big knowledge how to produce good electronic. And I worked 12 years for an electronic company. I know how big the issue was, how to achieve a proper soldering when it comes to assembly. Yes, that is a good example. There are also other examples where it doesn't work, but could be a local content anyway. I believe, as you know, more in entrepreneurship, so that's for me more local content than assembly lines. Or so I would rather look at education and education on job, what you do there. And I guess you do it in Zambia also very well, or trying to establish these dual education systems, which is most probably the key. I see also some other initiatives, as I told you, from Benin and from other countries where it works well, but it's always depending on one key institute or one key person sometimes. Okay. And I guess, yes, this event was very helpful because you developed a prototype and presented it, and now you got a lot of input which has to be now worked out and gives a lot of answers, but also additional questions. Thank you very much for the initiative.
Definitely worth a trial. At Strathmore Energy, my department, we concentrate on two things. The first thing is this, what's called capacity building trainings. And I'm not talking about just engineering level. Yeah? We do local trainings as well in Swahili, and so important is practical orientation with the product. And the other thing is adaptation. Yeah? What is your target group? Yeah? Another thing, the second, besides training, is pilot projects. And if there's one thing I learned is the experience you're gaining from these real projects afterwards. At the beginning of something, or before you have started something, you think you have an opinion or you think you have an idea. But believe me, once you have done it, yeah, and what you have learned out of it, it could be completely
sustainability aspect. I'd like to say about the training. If you talk about the ones that are locally assembled here, there is something to do with ownership. It's like if it was to be done here for me, I feel it would not only be cheaper, but people will like to associate with the equipment more or less. I mean, one of the things I know is that importing, especially when you are doing you are settling the equipment, importing all these parts, sometimes it's expensive, and at the same time it takes time. So if it is locally produced, perhaps Kenyans will also feel they own the equipment, and that sense of ownership, and perhaps it may improve the market, because they'll feel these things are not, it's not foreign. That is my feeling, especially when you go out there to the farmers and they want to use the equipment. So training, and at the same time, if it is done locally, then it simply means you'll have many more people trained, technicians trained, and you get to know more about the equipment. So for me, the level is training, and before you know it, yes, you can start small, pilot, whatever, but at the end of the day, we get it locally assembled, and I think that would improve the market. For me, I must say it was a learning experience today, and thank you so much for this initiative.
Thank you very much for your feedback, your contribution. Before you are allowed to leave the panel discussion, I would like to ask to the audience if somebody would like to say something about this last question that I had, if local production or the approach we have shown you today, if this can contribute to decrease the challenges.
Yeah, thank you very much. Challenges definitely are there, and I can't remember his name, but he told us here attitude change is a big problem in our country here, and I believe in African countries, because some people can't read me. I've been teaching for the last 15 years. So I went for a wrong profession, dirty. So you can see that's now attitude, and it will take time. We are used to having the then the way the white man used to sit in office, some people still want that job of a white man sitting in that office and probably money flowing in. So those are all attitude, those are challenges, and that's what contributed to weak training very few people. Right now, as you're talking, Strathmore University is the one having the most sophisticated renewable energy training programs and tools and machines. And we are among the first people who trained here 6 years ago. And the idea we are recruited from different technical institutions. Some of those institutions have closed down, the courses have collapsed. People changed because there was no money. They went to the original areas which they were trained on, and then the tools were given. Don't ask me where they went, please, because you can even imagine where they went, because there are no people. So you can see that 6 years ago, it's only Strathmore which started it. And people are coming now from Rwanda, from Uganda, from Tanzania, from Ethiopia, being trained in Strathmore University. The other institutions are not talking. There's nobody even to talk. So you can see it's total attitude first. And I agree with my friend, I can't remember your name. You gave me a card, but I can't remember your name. Attitude here is the main thing. And we are going to, it's a war, and we are ready for it. And more people, we are going through career, we are bringing more people from East and Central Africa to be trained in Strathmore. Other people don't have equipment, and therefore the skills, attitude being given is below average. And I'm sorry. Thank you.
I think from a technical point of view, certainly allowing us to assemble the units locally is providing us an excellent learning curve from both a training point of view and also to be able to explore areas where we can
because those are the ones that really can easily mingle with the local farmers because, well, they'll talk about these things. Well, I've been trained, I know about this. So basically to me, the distance between university and the local farmer is too wide. But local vocational training institutions, if they are integrated, there will be a good market selling point of this product to the local people. So I strongly feel to say, now that the product has been designed, localize it to a level where a technician, a craftsman can be able to handle it. They will talk about it to the local people. I think that's what I was thinking.
Thank you very much. We can now last contribution. You want to read?
This is just a follow-up to what the two guys have talked about. That you guys, the solar cooling team from University of Hohenheim, have given us the platform to build the assembly industry within our local market. It will be best of you to do a follow-up, kind of follow-up, especially regarding on the issues of insulation, what type of material do we use. You see, you've just thrown a challenge to us. I will go for polystyrene, someone else will go for something else. But we need to ask those questions. Will it be suitable for the intended purpose of the system? So there is need for you guys to either recommend the alternatives on what we use and the best mechanism on how to do the assembly. Because, I mean, that draws much more into this. So, in as much as that challenge is thrown to us, that let us focus on doing it locally here within the fact that we import the cooling unit on its own, and then the entire system we can do the local assembly. So there is need of the follow-up from you guys to ensure that everything is done as a part and to the recommended setup, how you intended it to be used. Thanks.
Thank you very much for your contributions, and a special thanks for all panelists. So you are really, thank you very much.